I'll be going very fast. In between, if you get doubt, you can ask me. Okay, you can stop and ask me. So what exactly the corrosion is? It is exactly the opposite of extraction. Extraction is nothing but extraction of metals from the ore. That is after corrosion, once the metal is being extracted, if it get rusted, if it get reacted with oxygen, and if it get rusted, again it forms a corrosion. So this is exactly opposite process of extraction, we can easily say. So this happens, the corrosion, exact definition for corrosion we can give as corrosion is defined as the destruction of metals or alloys by the surrounding environment through electrochemical or chemical or electrochemical reactions. Okay, this is the correct definition. Whenever they ask for a definition of corrosion, it carries 1 mark. You have to write this corrosion definition. So the next is how it happens. There are uh, the causes, the difference between due to the environmental condition corrosion happens. What type of environmental condition? Both the type of environmental condition, dry corrosion and the wet corrosion, in wet environment and also dry environment. If the corrosion appears in the dry environment, then it is called as dry corrosion. If it occurs in the wet environment, then it is called as wet corrosion. It is called as wet corrosion. Wet corrosion, it is also called as electrochemical corrosion. Electrochemical corrosion. What is dry corrosion? Dry corrosion occurs in the absence of moisture, whereas wet or chemical corrosion occurs in the presence of conducting medium. So dry corrosion involves a direct attack of metals or chemicals or metal surface. It involves the formation of electrochemical cells. The process is very slow in dry corrosion, and in the wet or electrochemical corrosion process is very fast. It is a rapid process. Whereas dry corrosion product produced are at the site of corrosion, where exactly the site depends. There only it happens. Whereas here in the wet corrosion, the rust is deposited at the cathode. It is deposition. Wet corrosion is the deposition, whereas the dry corrosion is the produced at the site. At this particular site, it will happen. So dry corrosion is a process of uniform corrosion happens, whereas the wet corrosion and depends on size and anodic part of the metal, depends on size and anodic part of the metal. So this is what the wet or dry corrosion or wet or electrochemical corrosion environment. In the exam, they will not ask explain dry corrosion and explain wet corrosion. Like that question will not come. Usually the question is like, what is define corrosion and what are the environmental conditions? Just if you write one sentence is enough. Otherwise also fine. So only definition is the main they will ask in the exam. After that they will ask directly electrochemical theory of corrosion. So what is electrochemical theory of corrosion? Electrochemical theory of corrosion explains us how the galvanic cell is formed. This is the formation of a galvanic cell. A galvanic cell is formed by the anodic part and the combination of anode and cathode surface. So this anode region, this is the iron metal surface where it contains an anode part and also cathode part. So the anode portion very activated, and this anode portion is affected by the corrosion, whereas the cathode part is not affected by the corrosion. Remember this. The combination of both anode and cathode forms a galvanic cell through the chemical reactions called as anode reaction and the cathode reaction. So what is the anode reaction? It takes place according to this theory explains how the anode reaction takes place in the anode part and how the cathode reaction takes place in the different medium conditions. Usually it happens cathode reactions in the medium where it liberates where it li- where it liberates OH minus ions from the cathode, that is the electrolyte solution, and Fe2 plus ions from the anode part, anode metal. So usually the reactions carries at the anode because we have chosen the metal as iron. So this is the standard reaction. That is what is standard anode reaction. Fe gives Fe2 plus 2E. That is the electrons we are giving. This is the reaction of Fe2 plus anodic reactions. So the next, the cathodic reaction. If you look at the cathode reaction, it happens in two conditions. One is the medium, that is the liberation of hydrogen, and the other one is absorption of oxygen. Two conditions. First condition is liberation of hydrogen. Second condition is absorption of oxygen. In both the conditions, cathode reaction happens. So this cathode reaction So this cathode reaction, it depends on the type of the medium, what type of medium we are taking, acid medium or anode medium. Acid medium, in acid medium, if you are taking a medium in acid condition, acids we are taking, more hydrogen liberate, that is H plus 2E, H2 minus, that is a H, more hydrogen liberates. This is called, this type involves the cathode, which is a hydrogen liberation. So when hydrogen is liberated, and this in the neutral condition, neutral or alkaline medium, hydrogen also liberated along with the moisture, that is H2O, OH minus and H2. So here also we get OH minus along with the moisture. In an acidic medium, the reaction in oxygen takes place. If the oxygen its absorption takes place, then H plus and OH minus. OH minus, O minus or O2 oxygen absorption takes place to give moisture. This moisture reacts with water. Why it is closing? So this reaction, moisture reacts with oxygen. Oxygen absorption takes place to give OH minus. So basically, cathode reaction takes place in the medium. Cathode reaction takes place in the medium. So in both the cases, whether it is hydrogen liberation or oxygen absorption, in both the cases, OH minus liberates. So this OH minus react with the Fe2 plus ion, which is the anode part, to give ferrous hydroxide. What is that? Ferrous hydroxide, FeOH twice. So this FeOH twice react with again with water to give Fe2O3, H3H2O. This is hydrated ferric oxide. Because we are taken metal as iron, it is forming a rust as hydrated ferric oxide. If it is taken other than iron, any other metal if you have taken, if you have taken copper, then it forms hydrated cupric oxide. If you have taken any other metal, if you have taken zinc, hydrated zinc oxide, or the zinc chloride oxide, like that, it will form. So any metal, if it happens, destruction in due to happens because of wet environment, that is electrochemical theory, the rust formed is metal oxides, hydrated metal oxide. Remember that hydrated metal oxides are the rust product. So this rust product is, there are three forms because iron it is formed. Iron is formed in presence of excess of, if more oxygen is present, then you will get a yellow colored rust. If limited oxygen is present, then you will get black color. This is how the reaction takes place in electrochemical theory. This electrochemical theory very important for the exam because it will be asked for 6 or 8 marks. Understood? Is there any doubt here in the electrochemical theory? Electrochemical reaction? Yes. No, nothing. No one is talking.
No, ma'am, no doubt.
No doubt. Okay. Understood? This is very clear. Is this clear? Electrochemical theory? Understood? No.
Yes, ma'am. Yes, ma'am.
Okay.
Yes,
The
ma'am.
next is factors affecting rate of corrosion. So what are the factors affecting rate of corrosion? Means first one what we discussed is nature of corrosion product. The next one is pH. Nature of corrosion product. The next one is anodic and cathodic area. Next one is pH, and the next one is temperature. It's E is not there, spelling mistake. Fine. So temperature. These are the four factors which affects the rate of corrosion. First one, if you look at the rate of corrosion, first one, what is that nature of the product? What type of product it is forming? That product, whether it is forming a protective coating or a not protective product. This depends on nature. So nature of the corrosion product means usually what is the product? Rust product, hydrated metal oxide. So in any metal, if in case of aluminium, it is forming aluminium oxide. In case of iron, it is forming ferric oxide, right? So this is the product it is forming as a rust. This rust, in case of aluminium, if you take the rust product, once the aluminium is rusted, it converts into aluminium oxide, and this metal oxide acts as a protect. It forms a protecting layer to the aluminium base metal because it is protecting. It becomes a passive. Hence, aluminium becomes a passive to the corrosion. In the same example, if you take in a iron, because a iron is a metal, here it is not a protecting layer. It is not protecting the base metal. So this is the example what kind of product it is forming, whether it is passivating the reaction or activating the reaction. That depends on what type of product it is forming. So this type of product, the formation of the product depends on what type of medium we are taking, whether it is the highly soluble or insoluble, highly stable or unstable, highly non-porous or non-porous metal, highly non-conducting or conducting, or a stoichiometric or non-stoichiometric. So these are the four conditions we are using. Based on these four conditions of the conducting medium, the type of the product depends, and based on the type of the product, the rate of the corrosion also increases. Rate of the corrosion also increases by increasing in the type of the product. So the next is factors affecting in case of anodic and cathodic area. So here just a cathodic area, anodic and cathodic area means here zinc is the anode. This is zinc is the where there is a hole, a small hole is present here. Here also pinhole is present, right? So smaller in case 1, smaller the anodic area. This is the case 1 iron. Smaller the anodic area, larger the cathodic area, more intense and faster the corrosion. And larger the anodic area, smaller the cathodic area, lesser the rate of corrosion. Just in a opposite. Smaller, faster the rate of corrosion, larger the anodic area, lesser the rate of corrosion. Only this difference. The next factor is pH. The pH factor depends on three conditions. First one is pH is less than 3, pH is 3 to 10, and pH is greater than 10. So here pH is less than 3. In case of pH is less than 3, in general, lower the pH, the corrosion medium, higher the corrosion. Lower the pH, higher the corrosion. Lower the pH means less than 3. If the pH range is from 3 to 10, in the presence of oxygen, it is essential because oxygen should present, then only corrosion can happen. In case of 3, that is pH greater than 10, only iron will not undergo corrosion because pH greater than 10 because of the formation of a protective coating like hydrous oxide. Instead of forming a ferric or hydrated oxide, it forms ferrous hydroxide as a coating. Excuse ferrous hydroxide as a coating. So this hydrous oxide forms a protective coating. It forms a protective coating on the iron surface above pH 10. So these are the three conditions where pH rate of the corrosion can be affected. The next factor is temperature. Temperature. Increase in temperature increases the rate of corrosion. Decreasing the temperature decreases the rate of corrosion. Depends on this, the temperature. It also affects on collisions. How we can explain? See, at less collision, at less temperature, there are less possibilities of metal ions of colliding. At a high temperature, there are more possibilities of metals to collide each other. So more the collisions, more the rate of corrosion will be increases. So the same apply if you apply to the conducting of the medium. The conductance of the medium depends on how the temperature increases. Increasing the temperature increases the conductance, therefore increases the rate of corrosion. You can see more collision happens. Decreases the temperature, decreases the conductance, because the conductance of the ion also decreases. So less collision, hence the rate of corrosion is also less. The next is types of corrosion. So the factors understood? Any doubt in the factors?
No, sir. No, ma'am.
Factors, is that clear? Factors.
Yes, ma'am.
Can I go to next? Shall I go to next slide?
Yes, ma'am.
So the next is types of corrosion. So types of corrosion, only two types, four types are there, but in your syllabus you have only two types. First one is differential metal corrosion, differential aeration corrosion, and here again differential aeration corrosion is different subdivided in subclassified into waterline corrosion and pitting corrosion. So what is differential metal corrosion is? It is also called as galvanic corrosion. The galvanic corrosion is nothing but, what is galvanic corrosion? It occurs when two different metals are in contact. When two different metals are in contact, this corrosion happens. Um, Coupled in presence of an electrode. When two different metals are in contact and they are coupled together, this corrosion happens in presence. Electrolyte should be present. So that type of corrosion is called as differential metal corrosion or differential aeration differential metal corrosion. So how it happens, differential metal corrosion, you can see in three cases, three causes for the differential metal corrosion. First one is difference in electric potentials of two metals. There is an electric path between the two metals, the electrical path between the two metals, and such as atmosphere and fluids such as the conducting medium also which happens. So these are the three major causes which can happen to the metal corrosion. Remember, what is differential metal corrosion means? Any example they give, if they take one but bolt is the one metal and nut is one metal, and take any example, latch is the lock is different, key is different metal, and a latch is metal is different, and a whole metal is different. So different plumbing, one pipe is different in the plumbing conditions. So any different conditions you can see, any two different metals are in contact, mean that comes under differential metal corrosion. So this differential metal corrosion, so this differential metal corrosion occurs. So what is that? Metal with a low electrode potential acts as an anode. Metal with high electrode potential acts as a cathode. So when iron and copper is in contact, these are the two different metals. How to identify which one is anode and which one is cathode means, the one metal which has low potential, low electrode potential acts as anode. The one metal which has high electrode potential acts as cathode. So this anodic metal undergoes oxidation, and whereas the cathode metal does not undergo oxidation. So what are the factors affecting this rate of corrosion is, the factors affect this corrosion is higher the potential difference between the anodic and cathodic metals, smaller the anodic area and larger the anodic area. So differential aeration, next is differential aeration corrosion. So this differential aeration corrosion is a type of corrosion where halfly immersed present in the medium. Halfly metal is halfly immersed in the medium. That halfly immersed metal inside the medium acts as the anode. The other half portion which is exposed to the environment acts as cathode. So this difference in the air gap, this difference in the aeration, where more contact with the dissolved oxygen and more contact with the atmospheric oxygen, whereas more contact with the dissolved oxygen acts as an anode. This portion acts as an anode and this portion acts as a cathode. So here differential in the air gap. So differential aeration corrosion is a type of corrosion that occurs when oxygen concentrations are access very metal surface. Oxygen different in oxygen concentrations. What is the type of reaction takes place here? At anode, oxidation, normal oxidation, that is M gives to Mn plus Ne, and in the cathode reduction takes place with the medium, that is 2H2O plus O2 plus 4 electrons to give 4H minus. So remember, whatever may be the type they ask, remember these two reactions, write commonly. Okay, take iron as an example. Wherever M is there, you replace M with iron, that is Fe, and write the anode reaction. Cathode reaction, this one, only one reaction, cathode, you write the same reaction for all the types. Whatever the type they ask, you write only these two reactions so that you will not go wrong, you will not miss the marks. Clear? Whether it is waterline corrosion or pitting corrosion, or differential aeration, or differential metal, or causes, factors, whatever may be, or control anything, whatever they ask, you remember these two reactions. Where there is a place of M, you take as an example of iron and explain and replace M with iron, that is Fe, and write the reaction. That becomes easy to remember the reactions. Clear? So here under differential aeration corrosion, we have another one, waterline corrosion. So what is waterline corrosion? What is waterline corrosion? So this is one example for waterline corrosion. So waterline corrosion is at near the waterline. So this is the waterline surface. At near the waterline surface, below the waterline, the portion acts as an anode. Above the waterline, the portion acts as a cathode. This is also halfly immersed. So the portion which acts as an anode below the waterline undergoes oxidation. The portion above the waterline surface, which is above the cathode, which is above the waterline surface, or acts as a cathode. So it undergoes cathodic reaction. So cathodic reaction happens in the medium, not in the cathode part. What is the cathodic reaction? The liberation of OH minus ions. And in the anode part, oxidation takes place. This happens with the liberation of electrons. So this is an example for waterline corrosion. What examples? The ship hulls, or a halfly immersed tank, or a log time immersed seawater. Excuse me. So this halfly immersed iron rod which is immersed in a water for a longer period. These are the two examples they can give for a waterline corrosion. The next is pitting corrosion. Pitting corrosion is where if a dust particle sits on the surface of a metal for a longer period, beneath the dust surface, the portion acts as an anode. The other portion acts as a cathode. This portion acts as a cathode. So this beneath the dust particle, this portion acts as a anode. The portion above other surfaces, the portion other surfaces acts as a cathode. So this pitting corrosion, it forms a pit. Pit means as the dust sits on the surface for a longer period, what happens? Beneath the dust particle, it destructs the metal surface, it forms like a hole, a pit. It digs the surface and it forms a pit. That type of corrosion is called as pitching corrosion, and the process beneath the just surface, it acts as an anode, hence it undergoes anodic reaction, and that is oxidation, and other portions acts as a cathode, hence the medium undergoes cathodic reaction, that is the formation of hydroxyl ion. So this is about types of corrosion. Any doubt here in the types of corrosion? Any doubt in the types? Any doubt in the types of corrosion? Students, are you
No, ma'am.
listening or only I am talking? Hmm? Sleeping? All?
No, ma'am.
Only Nitin? I think he is active now. Where are others? Meghana? Meghana, BR?
Yes, ma'am.
You are listening?
Yes, ma'am.
No doubt. Nobody is asking. Huh? Are you able to understand really? ಹೇಳ್ರೋ. Okay, next slide ಹೋಗ್ಲಾ? Shall I go to next slide?
Yes, ma'am.
The corrosion control. So here we are seeing how to control the corrosion by different methods. The corrosion control can be done by metal coatings. One is anodic coating, the other one is cathodic coating. So you have two different coatings. One is inorganic coating, the method of converting in the top layer, and the organic coating is just by paints and varnishes coating on the surface. This is organic coatings. So when it comes to the coatings, we have two different types. One is anode metal coatings and the cathode metal coatings. The anode metal coating is the base, the metal which acts as an anode to the base metal. By coating with that type of metal is called as anode metal coating. Cathode metal coating is the metal which acts as a cathode. By using that metal, coating on the surface of a base metal is called as cathode metal coating. So this coating's first process is galvanization. Galvanizing is nothing but it is a process of coating a zinc on the metal surface of iron. So what is that here? It is passes with the different containers. First take the iron sheet with the help of a rollers, immerse into the first container where it happens solvent cleaning. It removes the impurities. After removing the impurities in the first phase, pass the same sheet with the help of a rollers to the second container where it contains alkaline solution. So here it removes the degreasing process will be done, removes the impurities, grease and oil. After that, pass the same sheet with the help of a rollers into third. This is the pickling process by using 10% of H2SO4. Undissolved impurities, undissolved oil and grass can be removed here in the third container. From here it passes to the fourth. It has a water wash. You have to wash with the water and where to remove the impurities. Again, then after purification, pass with the other container. It contains a molten zinc where a thick coat of molten zinc at a temperature of 250 to 300. At this temperature, a coat of thin zinc is applied on the surface of a iron sheet. Once it is been done, pass the same sheet into the squeezer hot by passing a hot air. This hot air and squeezer helps in removing the excess of zinc present on the surface of a sheet. Once the sheet is obtained, the obtained sheet is called as galvanized sheet or a galvanized sheet. See, this galvanized sheet of iron is used in different applications, used in sheets or fencing wires, nails, all these are examples for galvanizing. Next is anodizing. Anodizing is Anodizing is what? It is a type of inorganic coating where the top layer of the metal is converted into oxides. Here we are not coating anything, just whatever the metal we are taking, we are converting the total metal into its product. What is the product form? The say for example, aluminium we are taking. Aluminium is the anode metal. So if it is this property is liberates to electron. The property is to liberate the electron. So once it connected to the external DC supply and immersed in the chromic acid or whatever the chromic acid and water moisture, what happens? It forms the aluminium oxide as a product, the rust. This aluminium oxide itself, the product of its own, the rust product of its own, it will act as a protecting to the base metal. So this type of protecting the surface of the metal is called as anodizing. Correct definition if you want to give, it is a type of inorganic coating in which top layer of the metal is converting into its oxide, which acts as a protective barrier and reduces the corrosion, is called as anodizing. So this is anodizing process. The next one what we have is, this is example, cathodic protection, sacrificial anode technique and impressed current technique. Sacrificial anode technique is here connecting the metal, one metal to the connecting the base metal to the other metal, which is an auxiliary anode, which protects by connecting this, which protects the base metal, that is the main metal. So the auxiliary anode, it might be magnesium. So here this is a steel pipe which is connected to the magnesium block. Magnesium is an auxiliary anode. This protects the steel pipe by connecting it. That means magnesium block is sacrificing its anodic property. So the next is impressed current technique. Impressed current technique, these are the examples of pictures that I am giving. The next is impressed current technique. Impressed current technique is it processes a positive current to the base metal when it is connected to the auxiliary anode with the help of